Okay, good morning you guys, hopefully all of you are doing well. Before we start the notes, go ahead and write down the title for today, our learning targets, and then go ahead and write down the definition for today. And then I'll go ahead and pause and then I'll explain after. Okay, so let's take it back to geometry. So when you were in geometry, you learned about trigonometry. There you learned how to find the sine, cosine, and tangents of angles. And if you may have remembered, the angles were usually between 0 and 90. So usually you would look at 30, 45, 20 degrees, 85 degrees, something like that. But you almost noticed that never ever did you have to find the sine of 0 degrees or the cosine of 90 degrees. So usually we would never look at anything below 0 degrees and above 90 degrees. But now, today we're going to learn about something called the unit circle. And this idea is going to pretty much help us be able to find the sine and the cosine and all the trig functions of angles that are bigger than 90 and less than 0. Okay? And obviously the ones in between 0 and 90. So in other words, we're going to be able to find, now with the unit circle, we're going to be able to find the trig functions for every single angle that you have. Okay? So this is how it's going to look, something like this. So you're going to get used to this and you want to memorize this circle right here. Okay, so the unit circle is a circle with radius of 1 unit. So this right here, it's a radius of 1, radius of 1, radius of 1, radius of 1. Okay, so say you want to find the sine or the cosine or something of an angle. Then you'll go ahead and just draw an angle right here. So this is your theta, and then you go ahead and you see that it makes an angle. Now what you can do is you can make a right triangle, because remember, when you were find sines and cosines, you would get used to using right triangles. So now here's what you're gonna do. So this right here, this side right here is gonna be 1. So that's your hypotenuse. It's 1 because if you think about it, this is the length of the radius, and this radius is the same length right there. Okay, so now let's go from there. We're going to go ahead and find the sine of theta. So sine of theta, remember, it's opposite over hypotenuse. So your opposite is y all over 1. And what's anything divided by 1? It's just that anything. So therefore your sine of theta is equal to y. Okay? Your cosine of theta, that's adjacent, right, which is your x right here, over your hypotenuse. And we label the x and y right here, guys, because we don't know what the lengths of these sides are. Okay? So your cosine is going to be x over 1. And again, x divided by 1 should give you x. And that's your cosine. Your tangent, which you should know, is going to be opposite over adjacent, which is y over x. Okay? So very straightforward. So remember, opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent. Your cosecant is this, but the reciprocal. So it's hypotenuse over opposite, so it's 1 over y. Your secant, it's hypotenuse over adjacent, so it's 1 over x. And last but not least, your cotangent is adjacent over hypotenuse, which is x over y. Okay, so very straightforward. Keep that in mind as we go on. Also, another thing, remember these circles right here, it's 1 0 0 1, negative 1 0 and 0 negative 1. These are the coordinates. So right here, so say they asked us, what if you want to find the coordinate for this point right here? This point right here, you guys, is going to be, and it's very important, it's going to be, your x is going to be it's going to be cosine of theta, sine of theta. And if you notice, that totally makes sense, because remember, your cosine of theta equals to x and your sine of theta equals to y. So you just label that for yourself. So x and y. Okay, so keep that in mind, and that'll make sense as we go on forward. Okay, I'll go ahead and let you finish writing this, and we'll continue. Alright, now go ahead and write this down, you guys. So write this down. I'll give you a moment to write it down. I'm gonna go ahead and pause and then continue. Alright, so now let's go on. So the unit circle, it's going to be a triangle within a circle. So I'm going to show you how to find the trig values of special right triangles. Okay, so first let's start off with our angle 30. So you know that this hypotenuse right here is 1. Why is it 1? Because the radius is 1, and if you move the radius at any point is 1. Okay, so if you think about it, this angle right here is 30. So the side right across from it, for you to get from here to this side, you would have to, again, usually you would multiply by 2, but here you have to divide by 2. So therefore, this side right here is 1 divided by 2. And hopefully you can see that. Why? Because remember, 1 divided by 2 gives you 1/2. What if you want to get to the other side? To get to this side right here, you'd have to multiply, remember, by square root of 3. Why would you multiply by square root of 3? Because you're at the side where it's 30 degrees. So now you get square root of 3 times 1/2, which gives you square root of 3 over 2. Okay? So square root of 3 over 2. Sorry, let me just write this right here again. Square root of 3 over 2. Just so it looks a little cleaner. Okay? So square root of 3 over 2, right there. Alright? Let's go to our other triangle. So what did it give you 45? If you have 45, here's what you can do. Remember, your hypotenuse is always going to be 1. So for you to get to this side right here, remember, divide by square root of 2. So you get, we can just do it scratch here, 1 divided by square root of 2. Again, we don't like square roots in the conjugate, so square root of 2 times square root of 2. And that should give you square root of 2 over 2. So this right here is square root of 2 over 2. Oh, and the beauty of this is, remember, this is 45 and this is 45, then this side must be the same as well, so this is square root of 2 over 2. And there you go. Okay? And therefore, this point right here is square root of 2 over 2, comma, square root of 2 over 2. This point right here, just to kind of bring it back, is square root of 3 over 2, 1/2. Okay, and last but not least, our 60 degrees. So what do we want to find this point right here? First, again, this is your hypotenuse, so this is 1. And then, since we're doing 60, we can't, this is 60 degrees and this is 30 degrees. So again, you could go ahead and jump to this side right here. And again, you divide by 2. So that should give you 1/2. And then, since this angle is 30, again, you could go ahead and multiply by square root of 3. And if you look at the work right here, it should give you square root of 3 over 2. And so this point right here is 1/2, comma, square root of 3 over 2. Okay? So just keep that in mind as we move on forth, and it's going to help you find the special right triangle, the angles. Okay? I'll let you write that down for a little bit and then we'll go from there. Okay, go ahead and write down example number 1 and then we'll continue. Okay, so cosine of pi over 6. So if you want to write it for yourself, this right here is the same as cosine. Remember, pi over 6, that's the same thing as, that's going to be the same thing as 30 degrees. Okay, so once you do that. Alright, so then you're going to go ahead and draw your, so you want to make sure that you draw your graphs. Okay, so remember, for our axes, you guys, just a quick recap. This is 0, this is pi over 2, this is pi, and then that's 3 pi over 2. Okay, so keep that in mind. Now let's go ahead and draw our 30 degrees. So 30 degrees or pi over 6, you know, is in between 0 and pi over 2. So therefore, your angle is going to be somewhere over here. Okay. And again, I'm just going to go ahead and draw just my circle right there. And then let this be 1, comma 0. Okay, because remember, we're going to be looking at the unit circle. Alright, so now, I'm going to go ahead and determine my sides. So first, this right here is 1, and this is 30 degrees. For you to get for 1 to the other side, this right here should be 1/2. Why? Because you divide by 2. And then this side right here should be square root of 3 over 2. So now, let's go ahead and find cosine of pi over 6. Cosine of pi over 6, that's going to give you, that's going to be x over 1. So that's going to be one of your trig functions. So what's my x right here? Your x is, remember, your adjacent over your hypotenuse. So that's square root of 3 over 2 divided by 1, which gives you square root of 3 over 2. And there you go. Remember, adjacent over hypotenuse or x over 1, which is just the same thing as x. Okay? So that's the long way. But now let's go to the next one. So tangent of pi over 4. You know that this right here is about the same, or not about the same. It is the same as tangent of 45 degrees. Okay? So I'm just writing that down. Remember, you guys, you have to be able to differentiate it between radians and degrees. So when you see pi over 4, you should automatically be thinking 45. Okay? But let's go ahead and draw a little graph ourselves again. So draw your little x-axis. and then I'm just gonna go ahead and draw like a little arc right there, and then 45 is right here in the middle, and then you're gonna go ahead and draw this right here, and that's 45 degrees. 45 degrees, and then you draw it down right there. That gives you a little right triangle. Okay, so your tangent. So first, remember, this side right here is 1, and then remember, to get from here we have to divide by square root of 2. So this right here is going to be square root of 2 over 2, and this is going to be square root of 2 over 2. Now, to go back to our functions, tangent of pi over 4 is going to equal to y over x. Why is it y over x? Because remember, this is the opposite over the adjacent. So now we go from there. We have square root of 2 over 2 divided by square root of 2 over 2. Now, if you notice, square root of 2 over 2 and square root of 2 over 2, that cancels, so therefore your answer should equal to 1. So that's your answer. Okay? And then now let's go to example C. Again, draw a little graph right there. So pi over 3. Again, and I'm doing this just for a little review. Sine of pi over 3 is the same as sine of 60 degrees. Okay? So again, I'm going to go ahead and draw my little arc right here. And then 60 degrees should be somewhere over here. And then, again, I'm just drawing a little triangle. So this right here is 60 degrees. And then this right here is 1. Okay, so this is 30 right here, so this item right here must be 1/2, and then this must be square root of 3 over 2. Okay, so when you see 60, the opposite should be square root of 3 over 2. When you see 30, the opposite should be 1/2. But now let's do the sine. So sine of pi over 3, again, it's the same thing as y over 1, which is just y, right? Because remember, y over 1. What's your y in this case? Your y is square root of 3 over 2. So therefore, it's square root of 3 over 2 all over 1, which is square root of 3 over 2. And that's your answer. That's how you do it. So when you're doing these, make sure to draw your graph. Make sure to make your little triangle, and then you'll go from there. You want to write that down, then we'll continue. Okay, now go ahead and write this down. So definition of the periodic function. Go ahead and give me a moment to write it, and then I'll go ahead and pause and we'll continue. Okay, so one thing that you're going to realize is that sine functions, or just in general, you notice that circles are periodic, so they could pretty much go round and round and round and round. That's the same thing that happens with our sine functions. So we have periodic functions that tell us that if, say, they give you an angle s, that angle s is the same thing as sine of s plus 2n pi. So take a look at this example. So say you wanted to find sine of 9 pi over 4. You know that 9 pi over 4 is the same thing as pi over 4 plus 2 pi. So therefore, sine of 9 pi over 4 is the same thing as pi over 4, which is equal to square root of 2 over 2. Okay? So that's what it means. It means that once you've gone 2 pi, that this pi over 4 ends up being the same as 9 pi over 4 in terms of like the sine. Okay? For the cosine is the same thing. Cosine of s plus 2n pi equals to cosine of s. So again, this example, take a look right here. Cosine of pi over 3 plus 2 pi. You know pi over 3 plus 2 pi gives you 7 pi over 3. But this right here, since it's periodic and you added that to pi, this cosine of 7 pi over 3 ends up being the same as cosine of pi over 3. And once you figure this out, that gives you 1/2. Okay? I know you might be like wondering like, how'd you get the 1/2, but that comes from doing like just evaluating the trig function. Okay? And then your tangent, this one's a little different compared to sine and cosine. So sine, it's plus 2n pi, and your cosine is plus 2n pi. But for your tangent, if you go around 1 pi, then it's the same thing as tangent of s. So take a look at this. Tangent of pi over 6 plus pi. Pi over 6 plus pi is 7 pi over 6, and that equals to 7. That equals to tangent of pi over 6, and then that gives you square root of 3 over 3. So again, that's just to show you that if you add a pi, that you'll still get the same tangent value. Okay? Alright. Now let's go to example number 2. So cosine of 13 pi over 6. Alright, so I'm going to go ahead, and before we do that, I'm going to go and do 13 pi over 6. Alright, you know that 13 pi over 6, if you get, that's the same thing as pi over 6 plus 12 pi over 6. right? Because pi plus 12 pi gives you 13 pi. Now, if you take a look at this, you get pi over 6 plus 2 pi. Why is it 2 pi, Mr. Rubio? Because 12 divided by 6 gives you 2 pi. So now, let's go ahead and find cosine of 13 pi over 6. Okay, that's just some scratch work right there, just to kind of determine. So cosine of 13 pi over 6, again, that's the same thing as cosine of pi over 6 plus 12 plus 2 pi. Again, you know that because of this right here. So what does that mean, Mr. Rubio? So now let's take a look at our periods. Remember, cosine of s plus 2m pi equals to cosine of s. So this right here, you guys, is your s. So therefore, this is the same thing as cosine of pi over 6. Where'd you get the pi over 6, Mr. Rubio? Again, since you're adding 2 pi, or multiples of 2 pi, then you know it's just that angle right there. So it's cosine of pi over 6. Now I could go again, do my little graph, so just do your graph, you guys, so you could help yourselves out. So remember, this is 0 and pi over 2. And then you could just do a little circle right there. You know that pi over 6 is about 30 degrees. So this is about pi over 6. Again, this right here is 1. Remember, since that's 30, this is going to be half of 1, so it's 1/2. And then this is square root of 3 over 2. Okay, now we go from there. You know, cosine of pi over 6 is the same thing as x over 1. What's your x in this case? It's the opposite. So, sorry, it's the adjacent. So therefore, it's square root of 3 over 2 all over 1, which gives you square root of 3 over 2. And there you go. That's how you find that value. I'll give you a little moment just to write that down. Sorry, I didn't, for some reason, I didn't know it was done, but there you go. Okay, write it down, then we'll go. Alright, now let's look at B. Sine of 13 pi over 3. So again, write down your 13 pi over 3. Try to determine. So first, what I do, you guys, is I just do pi over 3, just because it's an odd number. So then now, you know, it's the same thing as pi over 3 times 12 pi over 3. Again, you simplify that gives you pi over 3 plus 12 divided by 3, that's 4 pi. Now take a look at this. 4 is a multiple of 2, right? So isn't that the same thing as pi over 3 plus 2 times 2 pi? Yeah. So therefore, this right here is your s and this is your n. So so we have that. So now you have sine of 13 pi over 3 equals to sine of pi over 3 plus 4 pi. And because you know this is a multiple of 2 pi, that's just the same thing as saying sine of pi over 3. Okay? And now we continue. So therefore, again, I'm just going to make my little graph right here. Again, make your little unit circle. Your pi over 3 is somewhere over here. So pi over 3. And then we continue. Now, this right here, remember, this is 1. This, remember, since this is right here 30 degrees, then for you to get from here to here, it's 1/2. And then anything across from pi over 3 should give you square root of 3 over 2. So your sine of pi over 3, again, you guys, is y over 1. What's your y in this case? It's your opposite. So it's square root of 3 all over 2 over 1, which again gives you square root of 3 over 2. And that's your answer. Okay. Alright, so it's a procedure, you guys. So remember, you're just trying to find like the periodics. Then from there, you're trying to draw your angles, and then you go from there. Yeah. Alright, I'm going to go ahead and pause this, and then we'll continue. Okay, last concept for the day. So we're going to go ahead and continue these notes the next day, but this is the last thing we're going to learn today, and then we'll go from there. So go ahead and write down your even and odd trig functions, and then we'll go from there. Okay, so if you can remember from Algebra 2, you learned a lot about even and odd functions. So saying that like when you plug in a negative, like it'll give you a positive if it's a power of, if it's an even power, but if it's an odd power, then it would give you a negative. So that's pretty much kind of like the same idea here, but now we're looking at sines and cosines. So cosine and cosecant are even. So what does that mean? it means that cosine of a negative angle is the same thing as cosine of that angle. Secant of that negative angle is the same thing as secant of that angle. Okay? These two are the only ones that are even. Okay? So again, the cosine of that negative gives you a positive cosine of that angle, and secant of a negative angle gives you secant of the positive angle. Now, for sine, cosecant, tangent, and cotangent, it's a little different. So, sine of negative t is the same thing as negative sine of t. Cosecant of negative t is the same thing as negative cosecant of t. Tangent of negative t is the same thing as negative tangent of t. And cotangent of negative t equals to negative cotangent of t. So why do we have this? Because, again, we don't really like to work with negative angles, but we have these functions that will allow us to find trig functions very easily without having to have negative angles. Okay? Alright. Once we do examples, it'll make more sense. Alright. Let's go to example number 3. So go ahead and write down this example right here. Give me a moment to do that, and then we'll continue to the last problems. Okay. So cosine of negative pi over 6. So this right here, again. So you know that cosines and secants are even functions. So this is even right here. What does that mean? It means that cosine of negative pi over 6 is literally the same thing as cosine of pi over 6. Okay? And so we continue from there. Now we have cosine of pi over 6. So again, just draw your little graph. And as you might know, pi over 6, that should be about 30 degrees. So again, just draw a little circle right here. So that should be about 30 degrees right there. And then this is 1. Again, the opposite of 30, so practice this. Opposite of 30, you guys, that's going to give you 1/2. Opposite of 60, that's square root of 3 over 2. Okay? Now we go from there. Remember, this right here is your adjacent over your hypotenuse. So adjacent over hypotenuse, which is the same thing as your x over 1. Which again, what's your x? That's square root of 3 over 2. All over 1, which again gives you the answer, square root of 3 over 2. And that's your answer. Okay, so square root of 3 over 2. And that's how you do it. Very simple. So I think once you practice these pi over 6s, so at this point you might think, Mr. Rubio, like this is a little confusing. It just takes a while. You need to just be able to create, once you create your triangle, it becomes easy. Okay? So ask questions as you go. Alright, then the last one, sine of negative pi over 6. So this right here, this is not an even, this is an odd. So this is an odd function. So since this is an odd function, that means that sine of negative pi over 6 is in fact negative sine of pi over 6. Okay? So now I'm going to go ahead and find sine of pi over 6. Okay. So again, draw your little graph. Again, you have your unit circle. Pi over 6 again is 30 degrees. So you can easily use the other triangle that we just drew, but I'll just draw another one just in case. So this is 30 degrees. Again, this is 1, this is 1/2, and this is square root of 3 over 2. Okay? Then from there, your sine, again, your sine is the same thing as opposite over hypotenuse, which is the same thing as y over 1, which again is the same thing as, what's your y in this case? It's 1/2. 1/2 divided by 1. Anything divided by 1 will give you 1/2. Then 1/2 divided by 1 will give you 1/2. So therefore, you might think that's your answer. But remember, you want sine of pi over, you want negative sine of pi over 6. So therefore, you could bring it over here. And now we have negative sine of pi over 6 is the same thing as negative times 1/2, which will give you, move this down a little bit, that'll give you negative 1/2. And there you go, that's your answer. Okay, alright you guys, so now we're going to go ahead and take our mini quiz. So again, if you have questions, feel free to message me. As always, I'm available. I can explain it to you a little bit more in depth. But with that being said, good luck and have a great rest of your day.